दोस्तों, आप लोगों का स्वागत है ये मैकेनिक्स सिंप्लीफाइड लेक्चर नंबर 4। करेक्ट। दिस इज मैकेनिक्स लेक्चर नंबर 4। तो चलो, आज फिर हम लोग कुछ मैकेनिक्स की प्रॉब्लम देखते हैं। हाँ? कुछ डिफरेंट टाइप की प्रॉब्लम देखते हैं। सपोज यू हैव ए वॉल एंड one block is this is attached with the string, then another string is there. Correct. Now this string is connected to some. Correct. Now another block is there. We can say this is A, this is B, this is MA, this is MB, and we can take this angle as theta. Correct. Now we have to find out the tension in these strings. Suppose this is this, you can TA, T1, T2, and T3. This system is at equilibrium. इक्विलिब्रियम का मतलब क्या हो गया कि दिस सिस्टम बेसिकली इट इज नॉट मूविंग, सो एक्सेलरेशन एट एवरीवेयर blocks are not moving, so all the forces, they are at equilibrium. Correct. Now what we can do, we can, what is this is your MAG. Correct. And if we take the free body diagram of this, then TA will be nothing but MAG. Right. Now here, oh, this we can resolve as T1 cos theta, and this is your correct. I think this is clear. What is T2? Here, if you see, T2 is nothing but cos theta. Correct? And suppose if you resolve these forces at this point, this is your T1 sine theta. Here, T1 cos theta. Here it is T2, and here it is TA. TA, MAG. That means your T1 cos T1 sine theta will be what? It is equal to TA, and that is equal to MAG. That means T1 now MAG upon, since you know T1, you can know T2 also. T2 is nothing but now MAG upon sine theta to cos theta. Value of theta will be given in the question. Correct? That means this is nothing but MAG cot theta. If you make the free body diagram of this, since this is not moving, then what will happen? Here it is T2, here it is T3, and A is 0. That means T2 has to, T3 has to be equal to T2. Or this is also basically MAG. Correct? We can again see this. TA is equal to MAG. Then TA is equal to T1 sine theta and T1 cos theta. T1 sine theta is equal to TA, and that is MAG, and that is MAG upon sine theta. Correct? Now, here, correct? I hope this is clear. Any doubt in this? Please let me know. let us go to some another problem. In physics, actually, mathematics, sorry, mechanics is a very important chapter. If you know the mechanics, if you are master of mechanics, then in physics there is not going to be any problem. Another thing is in class 12, this electricity, electrostatics, magnetism, all these chapters are going to come. There also you will need this mechanics. And if you go for engineering, when you will go for engineering, let me tell you, there also this mechanics will come very handy. Correct? Now, let us take this. Suppose you have a sphere, and there are two inclined planes. Its mass is m. It is resting in these two inclined planes. Hello, good afternoon. So, this, you can take this as a cylinder or you can take this as a sphere, whatever it is you want to take. And this is resting between two inclined planes. Correct? Then, what are the normal reactions between the cylinder and two inclined planes? Correct? So this is very simple. Basically, if you see, so this is your 60 degree, this is your 60 degree, and this is your 60 degree. Now, it has a center. Normal reaction always acts perpendicular to the plane on which the body is resting, any kind of body. Correct? So, normal reaction from this will be like this, and it will pass through. Oh, this is wall. And here also, correct? Now, what about the weight of the body? Correct? Then you can now find out N1, N2, mg. Just see, this is the point. The three forces are there. And what about the angle between them? This is your 120 degree. This is your 120 degree. And this is your 120 degree. If I have taken this 60-degree angle, you can calculate according to your question. Correct? So here, what will happen? N1 sine 120 degree this is basically, what is this? This is your Lami's theorem. Lami's theorem says, suppose you have three concurrent forces, is your F1, F2, F3. Suppose this is your theta 3, this is your theta 1, and this is your theta 2. Then Lami's theorem, the Lami's theorem says F1 upon you can make use of. This is very handy. This is very good equation. Just remember this. Or you can do, if you don't remember, here in this case, what will be the result? N1 will be nothing but Mg and N2 will be nothing but Mg. If you don't know this Lami's theorem, then what can you do? You can do, you resolve this forces. This will be nothing but 60 degree. This will be nothing but 60 degree. And your N1 cos 60 degree plus N2 cos 60 degree. This must be equal to mg. And another thing here, this is your, if you resolve horizontally, then N1 sine 60 degree must be equal to N2 sine 60 degree. Means N1 and N2 are equal. Correct? So here we can say N1 cos 60 degree is mg, or N1 2 into cos 60 degree is what? 1 by 2. That is mg, or N1 is nothing but mg, and that is equal to N2. That is the result. If you don't know this, then you can resolve the forces horizontally and vertically, and you can do it. But in my opinion, please remember this. Correct? Please remember this. Note down this Lami's theorem. It is very handy in solving mechanics problems. You can again see this. I'm going to rub it. Let us take up a similar problem. Suppose you have a wall and correct. Again, one is sphere. This is the sphere. Suppose you have an inclined plane like this. This is the wall. So normal reaction from the wall and normal reaction from the inclined plane. Right? You may be asked to find out the contact forces. Contact forces means this is your suppose B and this is your A. Then now here again, if you see, you take the center. If you take the center, one thing is, suppose it has got a mass m, then this force will be like this. Correct? Suppose this is theta. Then there will be a normal reaction from this wall. It will be like, but minded it will go through the center. This you can say MD. And another normal reaction from NA. Correct? Same thing. This problem also you can solve. The Lami's theorem. First of all, you just mark this thing, theta, means this will be your theta. Correct? So, mg divided by sine, what is, this is your angle, opposite angle. You have to take the opposite angle. That is 90 plus theta. Then NB, or you can take NA. NA is very simple. It is sine 90 only. This angle only. What about NB? NB, this angle. What is this? This angle is basically NB sine 180. Correct? Very simple. Theta angle will be given to you in the question. You apply simply the sine rule and you can find out this is basically mg. So NA is nothing but mg upon into sine 90 is 1 only. MB is nothing but mg into sine 180 minus theta is sine theta only. This is how you can find out. Correct? This type of questions generally come in the exam. You can see this. Correct? If any mistake or correction is there, please let me know. Yes, of course, we can have alternate method also. What we can do? Simple, we can resolve the forces in horizontal direction. We can resolve the forces in vertical direction and we can solve it. Mind it, we have three conditions. If something is in equilibrium in a plane, I'm not talking about space. In a plane, if something is in equilibrium, some body is in equilibrium, then there should not be any net force horizontally, there should not be any net force vertically, and there should not be any torque, which is rotating the body. In case if the body is in space, then your equilibrium conditions are Fx in all three directions. your forces, that force must be zero, and of course, side by side, here, of course, when x and y, if your plane is x and y, then your torque will be z, but natural, correct? So I am very and very much thankful to the students who are watching this lecture. If you do not have time presently, then this is available on my YouTube channel. You can watch it later on. Correct? Now let us move further. You can note down these conditions. These conditions are very essential. There is one problem which comes recurring in the exam. Whenever you will find some wall is there, then you have this comes very often. Here, theta will be given to you. Of course, this is your, and this is in equilibrium. Here again, you can make use of Lami's theorem. There is no problem. Correct? Just see here, this is your mg. So in this string, suppose this is your T1 and this is your T2 and here T3. If you make the free body diagram of this, then T1 is nothing but mg. Now you know T1. Now you have to just find out what are these angles. That is all. This is theta. This is 90 degree. There is no problem. Then, of course, this is theta, the 90 plus theta, and this is 180 minus theta. So again, the same thing as the last question. T1 upon sine 180 degree minus theta will be equal to T2 sine, and this is T3. T3 is nothing but, now you know T1, you can find out T2 and T3. Correct? It's the same problem. Let us move further. A different kind of problem. Suppose you have a block it is resting on a horizontal plane, correct? You are applying a force. Now, this block has got three inclined sections. Suppose this is your, each section is, mass is m. Correct? Vertically, we have seen how to find out the normal force, but this is not, it is basically inclined, correct? So let us draw free body diagram. The best way is to draw the free body diagram. Suppose this is your block A, your B and C. Correct? Force is one thing is there, and there will be a normal reaction from block B to A. Correct? So normal reaction on A due to B. Correct? This is your theta. Then this is your theta. Then of course this will be your theta. Correct? Now just mark the forces. What are the forces it is having? One force will be your mg, because this block A is having the mass m, and of course there will be a normal force due to the horizontal surface. Correct? Due to the horizontal surface. Let us, suppose this is alpha. Correct? Now we have to resolve these forces. This is your NAB sine theta, of course, and this is your NAB cos theta. Correct? Horizontally, if we see, horizontally, if you see, then NAB sine theta is nothing but F. Because no other force is there horizontally. Correct? Your No other force is there horizontally. That means NB, NAB, NAB, if you know the theta, if suppose theta is given exact question, then in terms of F, this is your NAB. The only thing is we have to find out N1. What is N1? N1, if you see, this N1 is vertically, if you see N1 is nothing but mg plus none n ab cos theta. Correct? And AB, so now plus F upon. So this is how you can find. Then one more, this contact force will come between B and C. Correct? For finding out B and C, what we can do? We can take the free body diagram. Suppose if we take the free body diagram of B, if we take the free body diagram of B, then free body diagram will come like this. This is your B. Here again, one mg. Here again, suppose it is N2. Normal reaction, because those reactions will not be same. N2 and mg. What about this? This will be basically MAB is nothing but NBA. So here, normal reaction at B due to A. And here, normal reaction at B due to C. Correct? So this is the free body diagram of this thing. Here, if you see, now let us solve this. Let us first of all resolve this. And BA sine theta, and this is NBA cos theta. Correct? And here MBA, MBC cos theta, and here MBC sine theta. NBA, you know. Here, basically, you know, and this force you know, and this force you know. You have to find out N2 and NBC. Correct? Let us find out. What is NBC? Cos theta. Let us first horizontally we can see NBC sine theta. What is the horizontal force which is equating this? And that is only one, and that is NBA sine theta. Correct? That means NBA we have found out. Correct? So here NBC is nothing but F upon sine theta, because sine theta. Then what about N2? N2 will be equal to NBC cos theta plus mg. NBC now you know F upon. Correct? So likewise, you can analyze block C also, and you can find out N3. Otherwise, these contact forces A to B and B to C you have already found out. The only thing is the normal reaction due to the surface on the block C, you can find out like this. I hope this is clear. Correct? I'm going to rub it. I think there is no problem in this. I told you in the beginning that initially the problem will be simpler. Now we have reached up to the fourth lecture. Now the problems are going to a little bit tricky and very useful for you. The next problem is very interesting. Suppose you have a trolley. A man is standing on this trolley. Correct? This trolley is fastened to a pulley, and there is a hole. And he is holding this. Correct? Mass of the man is m, and mass of the trolley is capital M. Now, he is just pulling the cable to keep himself in the position, in the equilibrium position. Correct. He is just holding the string. That means neither he is going up, neither this trolley is going up or going down. So, first of all, the acceleration of the trolley is zero. The only thing is all the forces are balancing with each other. Correct? How to solve it? So, my point is, first of all, we have to see what are the forces acting on. Correct? If you see, there will be a tension in the string. And here also there will be a tension in the string. And it is the same string. So, since your string is massless and inextensible, that means the tension at every point on the string will be same. So, these things will be this thing. I hope there is no problem. Correct. What about the downward force? Downward force is M correct. Now, tension, there is no problem. Correct. Because we have taken it as a system. So this is what means 2t is nothing but M plus or T is equal to correct. Now, T, you know, tension in the string is this much. But there is one more force you may be asked to find out. Ki, what is the normal reaction by the trolley on the man? For that, you have to so on this, there there will be a normal reaction on the man due to the trolley, and there will be downward force due to the mass of the man. And another one thing is he is holding a string also. This force you should not forget. Correct? Should not forget this force. Now you can find out. And also N plus T is nothing but mg, or n is nothing but mg minus t, and t you know. If you simplify it, then you will get like this. Correct? How was this problem? Let me tell you, most of you not be able to do this problem. This problem is a tricky one. It has got a forces which visually are not easy to find out. But if you just see with the help of free body diagrams, then of course you can do it. Correct? So this was all about the today's lecture, and tomorrow we will have the mechanics simplified lecture 5. So be ready and attend that, because let me tell you, now the stage has come where you will get more and more very useful and good problems like this. So bring all your friends, everybody who are there with your, who are there with our friends in your school, colleges, and tomorrow's lecture is definitely going to be very useful. Correct? So, how was this lecture, or how was this video? Please do share me your thoughts and subscribe my channel immediately, so that you can know at least the time when my live lectures are being held in the day. So that is very important. Correct. Subscription is very important for me also, because more and more students are interested in these kind of lectures, the more and more I'll put in my efforts in making it very helpful for you. Correct. Generally, my lectures are in English, but if you are not comfortable with that, but whatever I speak a very easy English basically. That's why somebody was telling me in the chat that I always go a little slow, because the problem is I usually go slow because so that you can understand it. First of all, you have to understand it. Then another factor is English language. So in a very simple language, I try to make you understand these lectures. Correct? I can shift to Hindi also, there is no problem. If you tell me otherwise, most of my lectures are like this only. Correct? So tomorrow we will meet again. Until then, thank you very much.